What is Apache Kafka and what are its core components?
Apache Kafka is an open source distributed streaming platform that is designed for handling the real-time streaming data. And this is basically for high throughput, low latency, and fault tolerance purpose that it has built. And coming to the core components of the Kafka, it has a core components like brokers, topics, partitions, and producers and consumers. So the first one is the brokers. So brokers are like various servers that Kafka cluster has. So each broker is responsible for receiving the messages from the producers and storing them inside the topics and the partitions, and allowing the consumers to read the data from the topics or the partitions. And next thing is the topics like the data in the Kafka was stored or categorized in the form of different topics. Like each topic is something like a table in a database, and so the relevant data will be get stored inside the topic, and this is for allowing the parallel processing of a messages. And the next thing is the partitions. Like the data inside the topic will be categorized or divided as a kind of a partitions, like how the table in a database has created the partitions. This is also similar way, and this will allow us to connect the consumers in the parallelly and can read the data from the partitions or from the topics simultaneously, and this will enhancing the throughput. And the next thing is the producers. So producers are like services which can produce the data and can send the data to the Kafka. So the producers will receive the data from the producers and will get stored into the Kafka topics and the partitions. And the consumers, like who are actually reading the data from the Kafka topics or from the partitions, will take the data from the will subscribe to a topic and will start reading the data from the Kafka topics and the partitions. And the Kafka consumers are like two types. Like Kafka consumer, individual consumer can able to connect and can read the data from the Kafka topic. And Kafka consumer group is also available. Like multiple consumers can form as a group and can read the data from the uh, topic partitions. So these are the core components of the Apache Kafka. And also we have like Zookeeper. So this is the managing services of the Kafka brokers and maintaining all about the metadata about the topics, partitions, and the roles and everything will be taken care in case of the Zookeeper. Even in case of any node get failure, so the Zookeeper will assign another role as like leader node, and it will resume the operations without any interruptions. And also we can have also like schema registry. Like each topic has its own schema, so we can define the schema over there. And if you wanted to change the schema, right, so to support the schema evaluations, we can use this schema registry.
Explain the difference between a topic, partition, and segment.
Okay, so in Apache Kafka, the concepts like topics, partitions, and segments are like fundamental concepts, and these are the things that how the Kafka can store the data internal to the system efficiently. So topic is like a table name in a database. Like all the relevant data will be stored into the single table, right? So similarly in the Kafka also we have a topic is like a logical channel which records are published, and it can act as like a category or a feed name to which all the messages are sent to that one. And the topics are like each topic can handle the multiple producers and the consumers, and it will facilitating kind of a publish subscribe model. And topics can be again subdivided into the multiple partitions which are enabled for high throughput and more parallelism. And the next thing is the partitions. Like partition is a subdivision from the topic. Like each topic can have one or more partitions which are ordered and immutable sequence of records. And partitions are basically for scalability and improve the parallelism. Each partition can be placed in a different Kafka cluster, allowing the multiple consumers to read the data from it simultaneously. And order, like within a partition, the order is sequential order, and it can provide you the guarantee, but across the partitions, so there is no guarantee in the across order. Like the partitions, the ordering within the partition are like sequence in one partition. The next thing is the segments. Like segment is a kind of a file in the disk that actually the data gets stored in a file in the form of .log suffix format, and it will be stored into the disk. So this it has some specified size that we need to configure in the Kafka cluster. Once it reaches that configuration, it will close that file and it will open a new file. So usually the last segment file is kind of a active segment where the new messages are getting added to it. So inside the segments, the data will be get stored actual data, and the data can be read from these segments.
How does Kafka ensure message ordering?
So ordering in the Kafka, like it will be maintained in a multiple ways. One is like it follows Kafka follows like single partition guarantee. Within a single partition, Kafka can store the messages sequentially. Like whatever the messages that are sent by the producer, it will get stored in the same order, and also it will be assigned with the same sequential addresses within a single partition. So the Kafka can guarantee only on the partition level, not on topic level. Like topic has a multiple partitions, so each partition has its own ordering or its own sequence. And the next thing is a key based partitioning. Also we can it can follow, like when messages are produced, they can be attached with some specific key. Kafka uses this key to determine like which partition that a message has to go. So typically it uses a kind of a hash function. So since all messages are related to send to the single partition, so this also it maintains the kind of ordering. And the next thing is the consumer behavior. Like when the consumer reads the data from the partitions, so from each consumer from the consumer group can able to connect to only one partition at any given time, and then can read the data from it. Like if you allow the multiple consumers to read from the same partition, so it might mess up with the ordering. So to avoid this one, it will allows only one consumer from the consumer group can read the data from it. That's how it ensures the ordering of the message. And also on the producer side, we have some configurations like max in flight request for connection. So by setting this value to the one, so producer can send only one message at a time to the Kafka without waiting for acknowledgement. It keep send the one message every time, and it will get stored inside the partitions. So these are the different ways that Kafka structure can follows to ensure it has a correct ordering.
What is a consumer group in Kafka?
So in Apache Kafka, a consumer group is a kind of a fundamental concept that allows the multiple consumers work together to consume a messages from one or more topics. So the consumer group is like a collection of one or more consumer can formed as a group and connected to the multiple topics or to the multiple partitions, and can read the data from the partitions. Like each consumer group is assigned with a unique ID, and a unique ID with the partitions or the topics that they are consuming for. And this setup enables the parallel processing of the messages, and this enhances the throughput and efficiency while reading the data from the Kafka. And it has the many features, something like partition assignment. Like each partition in a topic can only be consumed by one consumer within the consumer group at any point of time. If there are more consumers, if there are more consumers are available than the partitions, the consumers which are it will be work like a one-to-one fashion. Like one consumer can connect it to one topic. If still if the consumers are more than top partitions are available, the remaining consumers are in ideal state. If there are less consumers are available than the partition, then one consumer can connect it to the multiple partitions and can read the data simultaneously. So this is how the partition assignment can work. And also next thing is the load balancing. Like whenever a new consumer or gets added to the added to the consumer group or leaves the existing one, Kafka automatically assigns the partitions to among existing active consumers. So this process is known as rebalancing. It ensures that all partitions are adequately covering by the available consumer groups. And next, it fault tolerance. Like if any at any point of time, if any consumer fails while reading out the data, it actually allows the other consumers to start reading from it, from the consumer group. So this mechanism ensures that message consumption continues without significant any interruptions. And the next thing is it also maintains the offset management. Like Kafka tracks of the offset, the position of the Kafka message in the partition for each consumer group. So this allows the consumers to resume from where they will left off in case of any failures or any restart. Offset can be committed like automatically or maybe manually, by providing the flexibility like how often that we need to do the commits. So yeah, these are all the things that will be part of the consumer group.